Times when you get up late and you work hard. Those times when you stay up late and you work hard. Those times. De repente. Y das
Good morning to all of you. We'll wait for one more minute before starting. Okay.
Good morning, ma'am.
Let's begin. Good morning to all of you. Uh, Now, today, what I've done is I have already updated your folder because I know that apparently your first exam is OT on Monday, right? So we are the opening batsmen, and I just hope that your innings in the beginning they are good. So I have put down every material that was used, including the recordings and the slides on your folder, so that you can access. Now, today, what we'll do is we will continue with technology and structure. That's number one. Number two is we will kind of do a little bit of revision of the entire course till date so that you get a perspective to the examination and that you don't have too many issues there, right? Because I understand that you don't have your book, right? We cannot do much about that, though I have tried whatever possible means from my end. But since it's in the hand of the publisher, we don't have a direct connect there. So what I have done, I've taken care to kind of not set questions which I may not have taught in the class, even if they are there in the chapter in the book, and you would have been able to go through it had you had the book. So I've taken care not to set questions of the kind. So please go through the recordings, your notes, and the slides, and you are good to go for the exam. Okay. So that is a disclaimer from my end, and let's hope that your exams go well, right? So now let's begin with where we dropped off from the previous class. Now, in the previous class, I had started with technology and structure. So my first question is, what is the broadest view that you can have of technology? Number one, and what is the meaning of technical complexity in Joan Woodward's research? Hmm. Yeah. The only response should not be to switch off your video. There can be many other responses also to the question. एंड क्यों वीडियोस को क्यों स्विच ऑफ कर रहे हो भाई? अभी तो तुम्हारे कॉलेज आने का टाइम आ गया है कि नहीं? सो ये सब
मैम
करके ये पैंतराज, व्हाई यू ट्राइंग इट आउट नाउ? Now, if God willing, before your semester is over, we will meet in the classroom, and that I can say will be a wonderful experience. I don't know whether it is going to be for you, but definitely for me. Yeah. So, like I said, our impact and our combined impact is only felt when we physically meet in the classroom. Okay. I firmly believe in that. Every class, it has an impact. Every teacher has an impact, and that impact can only be felt when you meet the person. Okay. I'm sure our first meeting is going to be memorable. So, अभी ये सब videos off करके बैठने का क्या sense है? So, if every situation is all right, next month you should be here with us in the campus, isn't it? Right or not?
yes ma'am.
Yes,
हाँ,
ma'am.
तो अभी ये सब बंद करो, these juvenile responses, and start answering my questions. अभी नहीं
Yes
करोगे
ma'am.
तो क्या मंडे को आंसर करोगे? Come on, fast.
Ma'am, technology is any thing which mankind has made to help the to solve the problems of mankind. Any
Solve the problems of mankind is such a broad and such a theoretical concept. Yeah, I mean, you have to make it a little more practical and little more understandable for students of OT. So
Ma'am.
we want to understand the broadest possible view, right? But then that doesn't mean that we will go into the world of theory. Okay, so what does it mean? What is the meaning of solving problems? What is technology? Give an example.
mostly when the tools and machines use
That's the
so that
point. That's what Aishwarya I told in the previous class also, that when we speak of technology, we automatically assume that, they are the equipments, the software, the tools, the machines, XYZ. But that is the narrowest possible view that you can have to technology. That is not technology in total. That is only a part of technology. So what is technology? Yes. Yeah, go ahead.
Ma'am, technology means the information, the equipments, the processes which we use for converting the inputs into outputs in any
Very good.
organization.
Okay, so the process of conversion, see, from the beginning, we are saying that organizations are open systems, isn't it? And that every open system has three parts to it. One is the input, one is the throughput, and the other is the output. So whatever throughput you require to convert the input into the output is called technology. So that can be information from Google, right? तुम्हारा information तो ज्यादातर Google से ही आता है, so we will consider Google as technology. ठीक है? टेक्स्ट बुक्स सब लोग टेक्स्ट बुक्स चिल्ला रहे हो। यहाँ पे अगर होते तो तुम्हें मालूम पड़ता कि हाउ मेनी टाइम्स डू यू ओपन योर टेक्स्ट बुक। समटाइम्स द कवर जो जो सेलोफेन कवरिंग होता है ना टेक्स्ट बुक पे, वो भी नहीं खुलता। ओके, and that Raddi wala takes that cellophane cover wala textbook also when you leave here after 2 years. So textbooks, I don't know how much of a part of technology that is. Yeah, but then still, yes, that helps convert the input into the output. And if you have any respect for your teachers, yes, teachers are also a part of that conversion of inputs to outputs. Then your technology, your equipments, your laptop, your software, your notes, your recordings, everything is technology. Okay, in that sense, if it helps convert the input to the output. Okay, so so we started, see, the idea here is with technology and structure that there is a huge debate in this area that, what is the impact of technology on structure? There are a group of theorists who say that it is too difficult to categorize the two of them, and hence there's no interest in the technology structure debate. So in order to make this more possible, what we have done, what your book has also done, is focus on the major contributions here. And that is how we started from Joan Woodward's research. Woodward was a British sociologist who concentrated her research exclusively on 100 manufacturing companies in Great Britain. I think you should be clear about this because that should also tell you the scope of her research, okay? So, and the limitations. हर एक research का एक scope होता है and उसी scope से limitations भी आते हैं, right? So that is the reason why I'm, parroting these words time and again, that this is where she had done her research. And there is a single dimension that she had introduced, and that dimension was called technical complexity. What is the meaning of technical complexity?
And the extent of automation in a manufacturing process.
Very good. The extent of automation that is found in any manufacturing unit or any manufacturing process was called as technical complexity. So the meaning of a dimension is that it can be categorized on a continuum. Continuum का मतलब समझ रहे हो ना, that there is a range. That means it can be called as low, it can be called as moderate, it can be called as high. Okay. So depending on this range, what Woodward has done is she has categorized her entire research in 3 categories. So organizations can be categorized in 3 categories based on that single dimension called technical complexity. So the first was unit or small batch. The second was large batch or mass. And the third was continuous process. ठीक है? क्या है ये सब? Abhinash Patnaik will tell us about unit and small batch. Yeah. Abhinash, क्या हो रहा है? कुछ भी कहोगे या नहीं?
Ma'am, I don't know.
You don't know. That's fine. But I hope by Monday you understand what we are talking. हाँ, नहीं तो वहाँ पे don't know का cost थोड़ा ज्यादा ही हो जाएगा. Yeah. खुशबू?
Ma'am, in small batch or unit production, they produce less amount of products, but the skill of people is high and technological complexity is low. And for example, tailors, they produce less amount of products and they are extremely skillful in their line of work.
Okay, okay. Fine. Anyone else? Anyone wishes to add on to this? Please go.
Ma'am,
The
unit
level of
production,
cost.
unit production thrive on the idea of customization. They organize production according to the needs of the customers. For example, shipbuilding, clothing, that prioritizes unit production.
And
Okay.
also, ma'am, their centralization is low in these kind of.
Okay. Now, when Sunit is talking about clothing, so if we are looking at retail units, large retail units like Zara, okay, so, can you call them only unit production? No, you cannot call them only unit production because they deal also with volumes, ठीक है? So volumes भी वो करते हैं. So they are a combination of unit and mass, ठीक है? So that brings us to the second category, which is called as large batch or mass production. So difference आप समझो. When you're talking of unit production, the concentration is on the unit. That unit can be a ship, that unit can be aircraft, that unit can be a designer cloth, that unit can be anything, okay? So the concentration can be a shoe, it can be a hat, it can be anything. The concentration is on that customization. So there are students who gave examples of Harley Davidson. They've given examples of Dell. Yes, they are all parts, good examples, which will fit the bill of the unit production because the concentration is on the customization of the unit. Okay? But when you come to large batch or mass production, you are not concentrating on the unit. What are you concentrating on? You're concentrating on the volumes that you will produce of that unit. So if you are producing a shoe, okay, so it's not only the customization of the shoe that is important, it is the number of shoes that you produce. Yeah, that is also important. Okay. So for example, typically, if you look at the iPhones, which was introduced, in the last year. So the idea is not only on the customization, the idea is also supplying the required number of volumes. So जहाँ पे आप volumes पे concentrate कर रहे हो, there you are in large batch of mass production. So it's not the units fixed now. How many of the units are you producing is what the large batch and mass production is looking at. Okay. So now, the last is continuous process production. That is slightly different. So what does that mean? Who's going to explain that?
Continuous process production means the extent of automation which we are using in the process, like how continuous the machines are being used for producing any unit. Like for example, in nuclear power plant, there we use machines on a heavy scale. So that can be a unit, continuous process production.
Okay. Anyone else who wishes to go? Good.
Also, ma'am, if we see a difference between continuous process production and large batch mass production, the difference is that in large batch mass production there is a sync between machine and man, whereas in continuous production there is more dominance of machine as compared to
Right. Okay, very good. So now, when you look at the difference between the large batch and the continuous process, the difference comes from the kind of technology that is used. So the extent of sophistication, the extent of automation of technology is very high in continuous process. So continuous process is, dominated by automation. And, when we come to structure and technology, we'll realize how difficult it is, or how different it is to understand the process units. Okay. So, that being the case, in continuous process, maximum technical complexity is experienced because the dominance of machines is the highest, whereas in unit, minimum technical complexity is experienced because the dominance of machines is the least. So those are the three categorizations of Joan Woodward, right? So now let's move on from here. See, we are not interested to understand technology per se. We are interested to understand technology because we find a link between technology and the structure that these companies can have. Okay, so let's look into that. Like I said, you can be totally confused here, but I want you to be completely in sync with me, okay? Just a minute. Just 1 second. Yeah. So this is what we need to see. And this is the most important takeaway of Woodward's research. Okay. Now, what she's done is, you can see, as I told you, I don't know whether I've told you in the previous class or not, you will not find this kind of a table in your book. I have only done it to make things easier for you. One go, one shot, you understand what all of this is. Now, if you look at the levels in the hierarchy, what do you have? You have a difference there. It is the least for unit, and it is the maximum for continuous process. Okay. So you have only 3 levels here. Mass is somewhere in between, and continuous has 6 hierarchical levels. Now let's look at the next. So, which should also tell you the shape of the organization. What is going to be the shape of the organization? In unit, it's going to be flat. Okay. In mass, it's going to be tall but broad. In continuous, it's going to be tall but very narrow. Okay, very narrow. Okay, so that's the kind of structures that you would have. Now, whenever you are talking about levels in the hierarchy, what do you talk about? You talk about vertical differentiation. Vertical differentiation. Always remember these. We have already spoken of this in length. So vertical differentiation is actually represented by the hierarchical levels in an organization. So that is what we are talking of here. Now let's move to the next point. That is the span of control of the frontline supervisor. It is 1:23 here, 1:48 here, and only 1:15 in process. Okay. Now, you need to also find out the interrelationships. Okay. Now, when you are looking at the span of control has an impact on hierarchy. Can you see that impact here? Can you see that impact here? Span of control has an impact on hierarchy. What relationship does span of control have with hierarchy? Forget about this.
Inverse relation.
Inverse relationship it
inverse
has
relation.
with inverse relationship with hierarchy. That means if you have more span, you will have less hierarchy. If you have less span, you will have more hierarchy. So let's look at less span and more hierarchy. Yahan dekho, span of control is the least in process. Hierarchy is the maximum in process, right or not? So that is what you will find in the next point, that is. Now, for us, the question is why you have the least amount of span in continuous process. Okay. Now, span of control is dependent on 4 factors. What are those 4 factors? Remember, previous chapter.
Spatial
What are those 4? Spatial differentiation, then what else?
Routine task, non-routine task.
Very good. Routine tasks and non-routine tasks. What else?
Expertise of
Amount of
managers.
interaction.
Great. And the last is the amount of supervision that a job requires. Okay. So span will not come by itself. There are certain things that will decide the span. So now when you look at the difference, see, mass has the largest span, whereas process has the least span. Okay. You know, the idea here is that in mass production companies, you find the existence of routine jobs, whereas in continuous process production, you find the existence of non-routine jobs. So the idea here is very clear, and this is what Joan Woodward also discovered, that if you have more instance of automation in your company, the amount of supervision that is required to maintain those automated units is very high. Okay, so that's the reason why the span of control is narrow. So if you remember the factors which impact on the span, if you have routine jobs, then span is wider because you don't require too much of direct supervision. If the jobs are more non-routine in nature, you have a narrower span. If the amount of supervision required is very high, you will have a narrow span. If the amount of supervision required is slightly less, you will have a wider span. Okay. So that's what you can find in mass and continuous process. Okay. So please remember, span of control has certain impacts and it is influenced by certain factors. So span of control will directly impact on the hierarchy. So, and it has an inverse relationship, and which is what can be seen from this table as well. Okay. So more the amount of automation in a company, more is the direct supervision required to maintain the extent of that automation. Now come to the third point, ratio of managers to non-managers. Okay. So it's 1:23 in unit, 1:16 in mass, and only 1:8 in continuous process. So isko dekho or bolo ki maximum amount of professionals can be found where? Out of these 3?
Continuous.
In process.
Continuous.
Okay. Maximum. For every 8 non-managers, you will have 1 manager. For every 16 non-managers, you have 1 manager. And it's 23, 1:23 in unit. Okay. So now this is linked with the last point, that is proportion of skilled workers. Proportion of skilled workers is high in unit. Okay, because there is one point that I have missed out. I will put that down. The proportion of skilled workers is high in unit because unit relies on individual expertise. It is also very high in process. Okay, you can find that. It's also very high in process, whereas in comparison to unit and process, you have low amounts of skilled or low numbers of skilled professionals in mass. Okay, so now, as I said, there is one point that I may not have put down here. You can take that down. That is the size of the organization. Size of the organization in unit is the smallest. Mass is large. Process is hybrid. That means you can also have small companies. You can also have larger companies. Okay. So that is what we see in unit, mass, and continuous. So did you understand ratio of managers to non-managers and proportion of skilled workers? So it's both of them are linked. So you have high degrees of skilled workers in both unit and process, and not so in mass. Okay. Now come to the most important part, that is the type of structure. Okay, type of structure is organic in unit, mechanistic in mass, and something called as hybrid in process. So let's do that. Okay. Now, let me first take the case of mass. Okay. Now, in mass, let me take a car manufacturing company. Any assembly line, any factory will give you an example of mass. Okay. Now, what is the structure? Mechanistic. Okay. Now, whenever you are looking at mechanistic structures, there are certain things, certain features that you find. What are they? So let's put that down first. Complexity is high. Why? Because the size of the company or the organization is large. Okay, you should understand that why complexity is high. High because the size of the company is large. Now these are formalization is high because there is a lot of coordination through rules and SOPs. Work is highly routine. Then centralization is also high. So if you have too much of standardization in a company, there is no need to decentralize decision making, which is what you find in mechanistic structures. Okay. So this is what you find in large batch or mass. So the nature of the work is routine and the environment is stable. You don't have too much volatility in the environment. So there is a stability in terms of market share and market presence. So you have more routinized operations here. Okay. Now let's come to complete different. Okay. And that is unit. Okay. So mass ka we have understood that it's a mechanistic structure. Unit may, let's take the example of, you give me an example in unit. Okay. Let me put it down like this. Let's take the example of Rolls-Royce. Okay. Now, what do you have here? Structure is organic, right? Now come to the features. Complexity. Complexity can be a bit of a confusion here. If complexity is low, why? Why is it low? Because the size of the company is small. It's a small sized company. So that's the reason why you can have low degrees of complexity, but complexity can also be high. Okay. Now, why is it high? Because of social specialization. In Rolls-Royce, complexity is high because social specialization or individual expertise of people is very, very high in unit. Okay. Then comes formalization.
Ma'am, can we also say it? Ma'am, it is high because it's a niche product. Can we also say that?
Yes. That's the idea. Okay. Now, formalization is low because the entire effect or the entire impact comes through customization. Okay. That's the idea. then centralization is also low. Why? Because decisions are taken by experts. Okay. So that is a typical organic design for you. Organic design can have high degrees of complexity because of social specialization. Then formalization can be low because the entire impact comes through customization. Then centralization is also low because decision making is always done by experts. So this is your unit for you. Now let's come to the confusion area. And what is that confusion area? That is process. Now, process may, let me take the example of Shell. Okay. Now,
Ma'am?
yes.
Ma'am, in the unit case, you have said that the complexity is high due to the social specialization. And if you see in the mass, then we can say that social specialization is low. So then it will be low, right?
How the complexity, complexity will remain high in mass. Why? Because of the size of the company. ठीक है? ये मैंने तुम्हें बार बार समझाया है that if the size of the company is high, horizontal differentiation will be more. And if horizontal differentiation is more, complexity will increase. Unit may, why I explained this point? Unit may, you may argue with me by saying that, ma'am, these companies are not very large sized companies. They're actually small sized companies. फिर भी उसमें complexity high क्यों है? Why complexity is high? Because of social specialization. Even if it's a small team, even if it's a small organization, but the kind of expertise that individuals have will introduce a high degree of complexity. That is why I spoke of it. Okay?
Okay, ma'am.
Okay. Now, in process, let me take the example of Shell. Now, this is a petrochemical company. Now, let's look at the structure, that is hybrid. Hybrid meaning it is combining both mechanistic and organic. Okay. Now, ये तो बड़ा confusing है. How, two kinds of structures will happen in one organization? The idea is like this. Okay. Now, if I'm looking at this structure, okay, if I'm looking at this structure, it is said that most often than not, process is divided, these companies are divided in two parts, okay? Now, if I'm looking at Shell, Shell is divided into the company plus the refineries, okay? That is very important, okay? Refineries will exist where oil is there, okay? So now these are process organizations. You'll always find, in most of these organizations, there is this division. So if I'm looking at a place like OMFED maybe, you will have the OMFED offices and you will also have the OMFED dairy units, okay? So the dairy units have a very different structure and the office has a very different structure. So that kind of a division you will find mostly in process, okay? And the idea in a hybrid design is that the bottom levels of the organization where the refinery is located is mechanistic, and the top and medium levels of the organization where people are located are organic. Okay. So why mechanistic? Why is the refinery mechanistic? Because of the degree of automation. Okay, automation, it will introduce a mechanistic design in the refinery or the bottom levels of the organization. Why? Because the extent of machines and the control by machines is very, very high there. But why would the medium and top levels of the organization be organic? Because the environment is volatile, number one. Work is non-routine, number two. And there is a flexibility required to adapt to the environment. Okay. So two things you are finding in one organization. So at one end, there is a great degree of automation where day in and day out, you're doing the same kind of job. So you'll have a more mechanistic structure there. But at the top levels of the organization, you may sense that the market is volatile and a lot of flexibility is required to adapt to those changes. So there you will find an instance of an organic design or organic structure. Okay. So you may say that does every process company go through this? Answer is no. There will be a degree of difference in the volatility that the organizations experience. Okay. So some organizations like Shell, nuclear power plants, they experience a lot of volatility in the market, even large steel plants. Okay. But whereas if you look at a bakery or a dairy or a distillery unit, the extent of volatility that they experience is less. Okay. So clear or not, everyone? Clarity is there or not? So why you would have these? So you can see here, in unit, it's always organic. In mass, it's more or less mechanistic. Okay. Whereas in continuous, you will have a combination of you have organic at the top levels, whereas the units which are completely automated will have a more mechanistic design. Okay. Now, if you look at yes.
Ma'am, in that sense, if we take the example of Amul, they have processing plant and also they have their offices where they do their work. So can we say it? So it should come in under mass production, not under
Yes,
continuous.
process. Amul is a good example of process. Okay. So
But then,
because
ma'am,
process,
volatility is less, ma'am, in dairy product market.
that is what I said also, that where would you find the difference? Kya likha hai maine? Degree of difference can be found in the volatility that the organization experiences. Okay. Because you may, argue that every organization which can be called as process is not going to be experiencing a great deal of volatility. No, but what these organizations have is a clear-cut division between the automated units and the office in itself. Okay. So, like for example, if you look at even Coke, okay, so the company exists and the bottling plants also exist. Okay. India is one of the only countries where Coke owns its bottling plants. Bottling plants are completely automated. Okay. But then the formula for the beverage, the kind of marketing strategies that Coke would adopt, the kind of flexibility, product differentiation and variation that the company does is not in the bottling plants. Yeah, it's in the company. So the company per se will have more of an organic design, whereas the bottling plant would have a mechanistic design. This thing you are doing day in, day out. The extent of automation is very, very high. So typically, if you go to the processing plants at Amul, what you would see, it's not very different from what you would find at Omfed or the Milk Mantra out here. Okay. I mean, in Odisha, you would find Milk Mantra and Omfed as the two biggest competitors to one another when it comes to processed milk and milk related products. Okay. So if you go to their dairy units, you will find very few people and you will find a lot of machines. So the extent of automation is extremely, extremely high. But the amount of supervision that is required is also very high. But then when you come to the company, you find a very different kind of atmosphere and you find a very different kind of structure. That is only to be found in process companies, not mass. Okay. Mass का example दे रही हूँ. For example, let us say that, most medicine companies have small dealers where, a lot of subcontracting happens. That means, when they, these companies come out with a particular composition and the composition gets the FDA approval. Okay. So, वहाँ उस वक्त क्या important है? That more and more numbers or more and more batches of the medicine needs to be produced. So that is produced in that factory, which is a clear-cut indication of mass production. तुम्हें क्या लगता है ये सारे companies अपने medicine खुद ही produce करते हैं? They have these subcontracted factories where mass scale production happens. Okay. Supposing if you look at the difference between the Oxford Group and the Serum Institute, Serum is called as the largest producer of vaccines in the world, right? तो उनका contract क्या था? What was the idea? That the Oxford group is going to come up with the patent of the Covishield vaccine, and when that undergoes the phase 1, phase 2, whatever trials are there, efficacy trials, mass scale production will happen in the laboratories of Serum. Do you understand the difference now? So Oxford group को कहाँ रखोगे? Oxford group is a part of process, right? Where lot of complexities you would find in the kind of work that is done. But when the work is already patented, that would get into mass. Okay? Supposing you're looking at a clothing retailer like Zara, abhi jo example maine diya tha, you can come up with a customized product, okay? And you can say that this is my design, okay? By the way, this is what most of the fashion companies do. If you are looking at Chanel, if you're looking at Doyer, you're looking at many other companies, okay? Jinke products humko pehna ya to own karna bahut acha lagta hai, right? You know, one part of them is unit, where the extent of customization is very, very high. Okay, that dur se bhi aap dekhoge, you will say that, oh, this is a product that is Chanel, this is a product that is this, but that part is unit. But another part of it is mass. No, volumes pe aapko produce karna hi padega. So these are companies which combine both the technologies. Got it? Right? But in Woodward's research, to keep it simple, what she had done was she could clearly differentiate between companies which are basically into unit production. They are not interested in volumes. Their entire impact is created through customization. Okay? There are, companies who are not interested in units. They are interested in volumes. Ki, if it is a shoe, I will produce 100 batches of shoe. If it is a hat, I will produce 1,000 units of the hat. So it's always volumes. Then there are companies which are combining both volumes and unit. That is what is called as process. इसी के लिए you find organic structure in unit, you find mechanistic structure in mass, whereas you find combination of both in process. Got it?
Yes, ma'am. Thank you.
Okay. So now, when we go to cost of operation is very high in unit. Need I explain why? If you have more of customization in your product, then the cost per unit of production will be very, very high. So those are the premium products for you. Then comes the whole idea of the mass production, where naturally mass production is meant to bring down the costs of production. Continuous also is medium. Why? Because it combines both unit and mass together. But kya difference hai between mass and continuous? It is in only this one dimension, that is technical complexity. So whatever, technology is utilized by the mass production companies, uska sophistication, and whatever technology is utilized by process production, there's a huge difference. The most sophisticated technologies are often found in process production companies. Okay. So that's the idea here. And so she could find a very, very distinct, difference in structure between unit mass and continuous process production. Okay. Now I can give you another example of companies which, try to combine both unit and mass. Okay. Unit and mass, but, you'll still keep them as unit only. So are you aware of this company called, are you aware of this Perrier Water? Are you aware of this? Well, you should be aware of it because, pani to pani hota hai. So hum log to sabhi wahi bolte hain. But then pani is not only pani. You can have still water, you can have sparkling water, you can have this, you can have that. And people claim that apparently still and sparkling water are different. ठीक है? So अपने को तो कभी पता ही नहीं चलता. But then Perrier is one of the most upscale brands when it comes to mineral bottled water. Okay. So very often you will find that in, premium airlines, they would be distributed in the business class or the, the platinum class or something like that. So Perrier comes from one of these streams found in a particular place in Austria. Okay. So, and it's considered to be the purest form of, bottled water. Okay. So this is a great example of unit production. They don't want this product to be available to all. You okay? So, and the cost associated with one single bottle of water is astronomical. You cannot imagine how much you have to pay for this small little bottle of water. और आप सोचोगे कि क्यों? Why will I buy it? Who would be mad enough to buy this bottle of water? People are mad and people buy. And this is a company that has done a lot of business, but their entire business is not making their product available to all. That's the idea. It is clear as that. Okay, so you would keep them where? You would keep them in unit. Rolls Royce. कौन उसको drive करेगा यार? Who will drive that in on the Indian roads? By the time you come back from whatever destination you are in, आपका गाड़ी Rolls Royce से मारुति हो जाएगा. You know that, right? But then would you say that people don't buy it? Of course they buy it. The kind of branding that happens for those kind of cars are unthinkable, right? So it's not a car that you are buying, it's something much more than a car. And the USP of those business models is not making it available to all. It is not a mass consumption. So that is kept in unit. So I hope that should differentiate between unit and mass for you. Okay. Now, so let's move on. So what have been the conclusions to Woodward's research? So the first is she could find a distinct relationship between technology and structure, but I would want you to concentrate on the third point. Ye dekho. She found that vertical differentiation increased with increase in technical complexity. Okay. And that was clear. What is the indication of vertical differentiation? It is the hierarchical levels. So maximum hierarchical levels were found in process production companies, which had the maximum levels of technical complexity or highest levels of technical complexity. So this was the first takeaway. Then if you look at point number 4, complexity, standardization, and centralization are high with the large batch or mass production because they are mechanistic structures, okay? Mechanistic structures, right? Now, there have been many criticisms also of this research. The first is the scope. The scope is limited to Britain and the scope is limited to manufacturing companies. So where do you place service companies? Can you place them anywhere? It's difficult to do that using Woodward's framework. And the second is, can you bring this framework to outside of Britain? Can you generalize this framework? Generalization has been done, but with mixed results. And the last criticism was that the data was collected by interviews. Okay, so when you collect data through the aid of interviews, will you be able to predict a causal relationship between two variables like technology and structure? The typical answer is no, but Woodward had tried to do that depending on whatever research she had done. So these have been some criticisms against the framework as well. Now, you may say that, madam, we are only talking of manufacturing companies. Can we talk of service companies also? Is there a framework that is allowing us to look elsewhere? Answer is yes. Okay. So what is that framework? That is the framework which was introduced by Charles Sparrow, or the second framework that we are going to study today. Now, Woodward's research had only one dimension, and that was technical complexity. But Perrow introduced two dimensions. One is called task variability, and the other is called as task analyzability. Okay, 1 and 2. Okay, and dimension का मतलब क्या है? Task variability can be high, can be low. Task analyzability can be high, can be low. Got it? So now, please look at the explanations on the slide and tell me what is the meaning of task variability and analyzability. this? Come on.
Task variability means the number of variations which we come across. Like normally we get to, when we do the routine work, if there we find the less task variability. But how if there is some unusual situation comes up in our way, then how do we solve it? Means how do we analyze that task? Then there we can see if we how fast we are analyzing it. If we are
Very good.
easily going to tackle the problem, then the task analyzability will be low, and if takes time, then the task analyzability will be high.
Okay, very good, very good. Now, ठीक है. Whatever Aliva has mentioned, usko let me give you an example and talk about that. So that will also be a little bit user friendly for you. So this takes me back to my MBA days, which were like almost 16, 15 or more years back. Okay. Now, when we have our alumni meetings and we meet our teachers, okay, and they have become really old. We have also become old, so they have become older. So very often, we had a trimester system, not a semester system. So 3 months we would get over. So we had a subject in the second trimester which was called operations research. मैं कभी नहीं भूल सकती. There are some memories that you have of every teacher and every subject, and some memories you will never forget. Okay, so and at MDI we also had a system of mentoring, and I personally believe that was very effective because our mentors were not our professors, but rather our mentors were our direct seniors. You have no link with your seniors, लेकिन seniors से ज़्यादा mentoring कोई नहीं कर सकता. Okay, they give you direct feedback and real time feedback about everything that is important to you. ठीक है? So what had happened was that operations research was one of the most dreaded subjects of the first year because the number of people who failed that subject was very, very high. It was a half credit subject, meaning mid semester mein khatam ho jayega. But still people were very frightened, and the meaning of F is that you will get thrown out of the institute, okay, which means that you will have to write the CAT exam again, which was the bigger nightmare कि एक बार मिल गया बार बार थोड़ी मिलेगा. So the idea was that जो भी है, you cannot afford to get F in any subject, and it was very easy to get F in OR. Okay, so I still remember sir coming to the first class and telling that this is a subject which the engineers will like and the non-engineers will hate. Okay, but I can't do anything about that, so you guys be prepared, and these are the topics that I will teach, and these are the topics I will not teach. अरे क्यों नहीं teach करोगे? Because you are supposed to know that. ठीक है? अरे हमको क्या पता? Engineers also did not know anything about it. And he said that all your exams are going to be open book exams. So we were breathing a sigh of relief कि चलो कोई नहीं, open book तो है. And I will never forget the 2 hours of end semester exam of this, now. Even now, I clearly remember the room and the tension and the nightmare that we faced. एक जन 10 किताब लेके गया था, notes भी लेके गए थे. And when we saw the question paper, let me tell you, the question paper was within what he taught. जो पढ़ाया था उससे दिया था. Okay. And we started opening, see, किताब लेके गए हैं, मतलब उसको खोलना है, okay? And you could also talk with your friends in the classroom. And for 1 whole hour, we are only opening books. Lekin we are not able to solve any of those problems which we thought we knew, ठीक है? And then at the end of 1 hour, it's a 2-hour exam. One of the guys got up and he shouted in that classroom कि अरे बंद करो ये सब. जो भी जानते हो कुछ भी लिखो, नहीं तो fail. We knew fail. So whatever we knew in that 1 hour, we crammed. कि चलो जितना मालूम है उतना तो लिख के आ जाएंगे. And उससे somehow we managed to pass by the skin of our teeth. Okay, skin of our teeth. And if you go and ask him कि sir मुझे कितना मार्क मिला और मार्क कम हो जाएगा. So out of fear, we were not even able to ask him what we had done. ठीक है? So in this case, if I, take this example and put it in Penrose's framework, task variability was not very high. Syllabus के अंदर ही था. उन्होंने promise किया था that he will set questions which are within the syllabus. But task analyzability was very, very high. हमें कुछ नहीं मालूम था. We didn't know anything. Every question is familiar, but we have no answer. अरे वो वाला situation आप सोच सकते हो ना, that you will get a question paper where you think that you know. अरे सारे questions तो familiar लग रहे हैं, इसको तो हम solve कर देंगे. But when you get to solving it, you don't know any answer. आपको कुछ नहीं पता चल रहा है. And another thing is also true that we were in a state of great panic. Okay, as students, you tend to panic very, very high. एंड पैनिक में हमें पता भी नहीं चला कि हमें क्या देखना चाहिए. जो भी देखना चाहिए, जस्ट इमेजिन आउट ऑफ 2 hours, 1 hour was spent on search and 1 hour was spent on writing. So you can imagine what marks we got. Okay, the highest mark in the class, it was relative grading. It was not absolute like you guys have. Absolute grading is easier than relative grading. The highest grade in the class was C and the lowest grade was F. So the people who got Fs, some kind of, I can't tell you how difficult it was to not see those people in the next trimester, which was the last trimester of the first year. मुझे भी लगा था कि मैं वापस घर आ जाऊंगी, and that too after 3 years of work, after spending all that money I've got to do higher studies and grade and come back home, it would have been the worst thing of my life. And when we meet him after 17 years, he says कि आपको OR की classes याद है? आपको कैसा लगा था वो class? What answer you will give that person? That, the nightmare that we faced, we are never going to forget that nightmare. And that nightmare was not because of variability. You knew what OR was. The nightmare was because of analyzability. How I will solve? This is my problem. But how I will solve? Do I know that? Answer is no. Okay. So your companions or your friends in the previous section said कि OT का question paper कैसा होगा in terms of variability and analyzability. My answer is I always follow the middle path. Okay. I will not make it very easy for you by saying that variability is also low, analyzability is also low. I will also not make it difficult for you by saying that variability is high and analyzability is high. So it's always moderate. So you will have a chance to do very good, but if you read and come, that is the only disclaimer. Okay? So now did you understand what is variability? Variability is the exception that you face, the problems that you encounter in your job that you have to solve. That is called variability. Okay? अगर ज्यादा problems नहीं है, variability is low. अगर ज्यादा problems है, variability is high. Analyzability is that yes, I face problems, but do I know a solution? Or may yes, there are problems, but do I know the solution? If answer is yes, analyzability is low. If answer is no, analyzability is high. Okay, that means I'm spending a lot of time to find out a solution for the problem, and I still don't know whether my solution is right or not. Okay, so ऐसे भी हो सकता है, and I just hope that you don't encounter this in any subject because, mind you, you don't remember your teachers for the best of reasons. Like, was there with us. अच्छे अच्छे टीचर्स आपको कभी याद नहीं रहते, लेकिन जहाँ पे आपको नाइटमेयर एक्सपीरियंस हुआ है, उनका चेहरा, उनका सब कुछ आपको हमेशा याद रहता है. I mean, that's the truth. So that's the meaning of variability and analyzability. Now, these are very commonplace things, but can it combined to form organization categories? Answer is yes. That is what Pero has done. And Pero has extended his research to both manufacturing, service, basically any kind of job. Okay. So now let's take a look at this. See, these are the questions that you ask for variability. These are the questions that you ask for analyzability. So variability may, how many of these tasks are the same from day to day? To what extent would you consider your work as routine? How repetitious are your duties? If you have more repetition, if you have more routine, then variability is low. Okay. If you have more non-routine, if you have less of repetition, then variability is high. Then comes analyzability. To what extent is there a clearly known way to do the major types of works that you normally encounter? To do your work, to what extent can you rely on standards and procedures? To what extent is there an understandable sequence of steps that can be followed to do the work? Okay, so if you spend less time to search for solutions, then analyzability is low. If you spend more time to search for solutions, analyzability is okay. So that is the kind of moderation that we will have here. Okay. Now let's combine these two dimensions. इनको combine करके हमें क्या मिलता है? Let's take a look at that. Now that is this. Okay. This table for you. Now, once again, this table will not be found in your book, but I have put down this table so that, it's easier for you to understand and compare also. So let's start with the first, okay? And that is called as routine technology, okay? Now, routine technology, mein, what do you have? Variability is also less and analyzability is also less. What does that mean? What does that mean?
Because it's
Fast.
a routine task, ma'am, because it's a routine task, so variability will be low. And if variability is low, there is no need for analyzing anything. If there is
Okay.
no
Okay. Anything else? Somebody, very good. Someone.
Search.
Yes, these are repetitive activities, and repetitive activities may, like Shada is saying, that even if, you do not have too many problems, and even if you do encounter them, you do know the answer to those problems. Okay. So this is called as routine technology for you. So don't go by the use of the word routine technology. Look at the kind of examples which have been given. Clerical staff, typists, secretaries, then store managers, all of them would come under the first category, that is routine technology. Now, just bipolar opposite, let us take, okay, bipolar opposite. That is non-routine technology, okay? So non-routine technology may, what do you have? You have high task variability and high task analyzability. What does this mean? Yes.
Ma'am, because there is more unpredictability. Since we cannot predict that.
There are variability, meaning the problems that you encounter in your day-to-day work is very high. Okay. And often you do not have required solutions to those problems. So both analyzability and variability become high, making it a very unpredictable zone. Okay. So what are the examples? Examples are strategic planners, top management teams, then R&D teams. All of these can be categorized in non-routine technology. Non-routine technology. Problem is very high and solutions are not easily defined. Okay. New product development teams, all of these would come under the category of non-routine technology. Okay. So this and this are completely different. Now come to the other two bipolars. One is called as craft and the other is called as engineering. Okay. Now, what is the meaning of engineering? Engineering may task variability is high. Task variability is high, meaning the number of problems that you encounter can be high, but task analyzability is low. What does that mean? That means you know how to take care of the problems that you encounter in your day-to-day activities. Okay. So you have high task variability, but you have low task analyzability. So what are the examples that can be given here? Look at the kind of companies which are coming in here. These are not manufacturing companies for you. So you have accounting and legal research firms. You have tax consultants who can be placed here. Then consultancy firms which can be placed here. अच्छा, तुम अपने जॉब को कहाँ पे प्लेस करोगे? तुम्हारा जो जॉब होगा, where will you place it? It will come here. Okay. Your task variability can be there, but task analyzability will also be there. Okay. That much you get clear. If I'm looking at my job, where will I place it? It's here, engineering. Okay. Most of it, day-to-day exceptions are there. Believe me, all the 4 sections, I'm taking the same course, but all 4 sections are different. Okay. And there is a different way to tackle the 4 sections that I experience. And I can see this difference even in the online medium. Offline hota to or clarity se wo difference dikhta. Okay. So variability is very high, but analyzability is not that high. I know what to do with the kind of problems that I encounter. Okay. So tomorrow, if I'm writing a paper and I'm not able to get it published, there are 100,000 ways in which I can get help to get my paper published. That is the idea. Okay. So I keep it here. Now move to the other quadrant. Okay. Just opposite to engineering. वो क्या है? That is called as craft. Okay. Now यहाँ पे you will not find very many exceptions. Exceptions ज़्यादा नहीं है. Okay. या तो variability ज़्यादा नहीं है. But whatever problems are there, they are difficult to solve. That is why task analyzability is high. Okay. So if you are looking at architects, if you are looking at chefs, you're looking at fashion designers, then these kind of jobs will come under craft. Okay. Master technicians, these type of jobs will come under craft. That means too many problems are not there, but whatever problems are there, they are difficult to solve. So they would be kept under craft. So now are we getting a picture of routine, non-routine engineering and craft? Yes or no? हाँ? कोई भी उसमें doubt है? बताओ. Okay. So now what is important for us is we have to understand that there is a structural linkage here also. Okay? So what kind of structures will you find where? Now, let's first look at routine technology. Routine is completely mechanistic because, it's just like the mass production in Joan Woodward's research. So everything, centralization is high, formalization is high, complexity can be low, moderate, and high depending on size. Okay. If size is less, complexity is low, size is more, complexity is going to be high, but the structure is mechanistic. Whereas if you look at non-routine में structure क्या होगा? It will be organic, right? So complexity is high. Why? Because of social specialization. These are highly, skilled people at their jobs. Okay. So if I'm looking at an Oxford group, where will I put the Oxford group? It will be in non-routine technology, right? Problems are many, but solutions are very often unknown. All the R&D groups that have been involved in the development of the COVID vaccine, whether you look at Pfizer, you're looking at Bharat Biotech, you're looking at Serum, you're looking at so many Moderna and all of those vaccines which are used, even the Sputnik. Okay, all of their R&D teams can come in non-routine technology. That means problems are many, but solutions are not often defined. Okay, so what kind of structures do they have? Organic with high degrees of complexity because social specialization is high, but formalization is low and centralization is also low. Okay. Now we will come to craft and engineering. Craft may very often you will see that you have an organic design. But what is craft for you? You have not many problems, but you have difficulty in taking or in finding an answer or a solution to the problem. So craft ka jo design hai, that is organic. And you will find that complexity once again is dependent on social specialization. In both these areas, non-routine and craft, you will find experts. Okay? Experts. So again, organic structures in craft, but whereas engineering, जहाँ पे बहुत सारे jobs होते हैं, whether the degree of expertise depends. You can have experts, you can also have people who are not very skilled. Okay. So moderately mechanistic structures you will find. They're not completely mechanistic like routine technology, but moderately mechanistic definitely. Okay. And why moderately mechanistic? Because you have a number of exceptions that you may encounter in your day-to-day problems, but all those exceptions can have rule bound or whatever, planned solutions to them. So there was a question that came in one of the sections that if there is a market research firm, where do you want to place it? Got it? If there is an analytics firm, that means basic job of the firm is data mining, okay, and proposing solutions based on that data. Engineering technology, you find many exceptions, many problems, but you know how to solve the problems, or you can find solutions to the problems, okay? So I will stop here, and if there are any questions, I will take them up. Please go through them. Please read these slides on your own so that you get some kind of a balance here. That is going to help you out. Now, let me just take you through the entire course once again, whatever we have done up till now, so that you are on base for the next semester. Now, we started with the basics of organization. So what is the meaning of an organization? What are the features that an organization would have? Then we have gone through two different views, perspectives to organizations. One is the open systems view and one is the life cycle view. Okay? So ye dono aap padhe. Then there are certain characteristics of organizations as open systems. Okay? So we have gone through so many characteristics like equifinality, like negative entropy, like balance between maintenance and adaptive activities, like the tendency for growth. All of these, 8 to 9 characteristics we've gone through. And then from the introduction, we moved into the first major chapter, which is the 3 pillars of organization structure. What are the 3 pillars? Complexity, formalization, and centralization. So what is important for you in complexity? That you understand horizontal differentiation, vertical and spatial, and the linkage between the 3. Okay. Then comes vertical differentiation, where the entire discussion is on hierarchy and span of control. What can be the linkage between vertical and horizontal differentiation? Then the whole idea of spatial differentiation, and is there a linkage of digitization in business with spatial differentiation? That means you are expanding geographies virtually but not literally. Okay, so that is there. Then formalization. How will companies achieve formalizations? How do they build rules and regulations? What are the advantages? 4 major advantages of formalization to companies. Then comes centralization. And the last is how are complexity, formalization, and centralization linked? Okay. So once we completed the 3 dimensions of structure, we came to the determinants of structure. What will determine these dimensions? So the first topic that we have gone through is environment. So organization environment, what have we covered? We've looked at the 2 landmark contributions. The first is Burns and Stoker, the categorizations of structures as mechanistic and organic. And the second is Emery and Trist, where they have given you 4 different categories: placid random, placid clustered, disturbed reactive, and the turbulent field. Okay. And then we went on to the 2 different parts of environment, the generic, which can be analyzed using the Pestel framework, and the specific, which can be analyzed using the Porter's 5 forces. Okay. And from there on, we moved on to organization expansion through organic or inorganic growth. And as our discussions unfolded, inorganic growth has become more important than organic growth. So what are the IOR frameworks in inorganic growth that we've gone through? Resource dependence. What should you be reading? Symbiotic and competitive interdependencies. Population ecology. What should you be reading? You should understand the difference between ecological and incremental change, innovations and differentiations, R versus the K strategy, generalist versus the specialist strategies. The last, of course, is the transaction cost. which should tell you that what is the meaning of transaction costs, why companies would encounter transaction costs, and what are those IOR strategies that companies adopt to minimize their transaction costs. Okay. And in technology, what have we understood? We've understood the meaning of technology. Okay. The meaning of Woodward's classifications of small batch or unit, large batch or mass, and the process production on the basis of one dimension that is called as technical complexity. And then we moved on to the second framework, which is PERO. What is the meaning of variability and analyzability? What is high and low variability? What is high and low analyzability? And we have 4 quadrants: routine, non-routine, craft, and engineering. Got it? So this is what you are in effect studying in total and coming for the exam. Please study and come, and your exam is going to be very, very good. Okay. So all the best to all of you for your exams on Monday. Please do well in all papers and do the best in OT. Okay. So take care of yourselves and bye. Okay. We'll meet after the mid semesters. Bye-bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.